We shall commence this module by studying the pollution control techniques in brief. We analyze tradable pollution permit as an economic instrument for pollution control in the context of the practical applications of this instrument to the real world pollution control problems. We assume that a region has set some specified targets for pollution reduction set through the political process using the scientific inputs on likely damages and economic inputs on both the damage cost and control cost. Such targets are typically of two types. The first type involves the target reduction in emissions output across a specified set of pollution sources. For example, the target reduction of CO2 emission or greenhouse gas emission by the power stations. The second type is a target improvement in ambient environmental quality, which may take a form of target improvements in ambient water quality by increasing the dissolved oxygen levels in an estuary up to a specified level. Other examples of ambient environmental targets include the setting upper limits for substances in drinking water, example for lead or nitrates, etc. In this module, we set out to study tradable permits as a potential policy tool to tackle the pollution related problems. Focus shall be laid on efficiency or social cost minimization as the main criteria of interest. We may also consider distributional effects of permits and on political acceptability and environmental performance. After studying this module, you shall be able to understand the concept of tradable pollution permits, to identify the efficiency properties of tradable pollution permits, to understand the design of permit system and how they are allocated, to discuss the problems associated with the use of economic instruments like TPPs. Let us now understand the efficiency properties of tradable pollution permits, which is known as TPP. The idea of tradable pollution permits, TPPs, has become quite popular with environmental economists over the years. The major problem in handling the problems of externalities like pollution is the absence of a sufficiently defined and enforced set of private property rights with regard to the environmental resources. While introducing the concept like right to pollute, the main idea behind TPPs is to allocate such rights and make them tradable. Once such arrangement is made, a market for right to pollute emerges where this right is assigned a market price. This price provides a suitable incentive to polluters to adjust the emission levels such that a cost minimizing solution is reached under the certain given conditions. However, as we will see, TPPs have their own set of problems. In this section, the basic theory of TPPs is first set out, and later on in the module we will review the allocation procedure of TPPs and the problem areas with TPPs. For example, the current emission of carbon dioxide emissions from power stations in a given region is say 1 lakh tons per year, and the regulating authority has set the target reduction at 50,000 tons, leaving 50,000 tons of continuing emissions. So, the authority issues 50,000 permits to polluter firms either by distributing them on pro-rate basis with existing emissions or by auctioning them. Each permit allows the holder to emit 1 ton per year of CO2. The polluter's discharge may be deemed illegal if the polluter does not possess sufficient permits to cover them. The firm are allowed to trade permits and one assumes that firms with relatively high marginal abatement cost, known as MACs, might find it profitable to buy permits, whereas the firms with the low MACs might sell their permits at an established price, assuming the initial allocation not to conform to the least cost one. This is shown in the figure, where the horizontal axis measures both emissions and permits held by the firm. Without any intervention, the firm do not exercise any control over the emissions and operates at EF. Suppose now that the tradable pollution permits are introduced at a market price for the permit of P star. It is the equilibrium price in the permit market determined by the intersection of demand and supply. Firm's demand curve for permits is its MAC curve, and so the aggregation of MAC curves across I is equals to 1 goes to N firms in the control region, that is summation MAC is the regional demand for the permits. The permit price will fall or rise depending upon the authority's decision to increase or decrease the supply of permits given a permit demand curve. Each firm compares its MAC schedule with the permit price to decide how many permits to hold. If price falls, the firm will hold more permits and control fewer emissions. The firm will choose to hold E star permits. If it holds anything below this level, it will be cheaper to buy permits as compared to reducing emissions, as MACs lie above the permit price. However, if the firm initially holds more than E star and thus can emit to the right of E star, it will choose to sell the permit since the price it can get, that is P star, exceeds the marginal cost of making permits available for sale by reducing the emissions. A firm with higher cost of controlling pollution will wish to hold more permits given a permit price of P star. The intuition behind the least cost property of TPP will become clear if we realize that say firm 1 equates the permit price with its MAC schedule, so that for firm 1 we get MAC1 is equals to P star. Another firm 2 will make the same adjustment to its emission levels in the face of P star, and if all the N firms do the same, then we get MAC1 is equals to MAC2 is equals to MACN is equals to P star, which for a uniformly mixed pollutant is a necessary condition for cost minimization across the total of the discharges. These reactions by firms move them to their cost minimizing positions. Alternatively, we could view TPPs as a way of maximizing the reduction in emissions subject to a given total expenditure on abatement. For a uniformly mixed pollutant, we know from the above that this involves an equality of MACs across the polluters. Moving on to discuss the design of permit system. One generally comes across two designs of permit system: an emission permit system known as EPS and the ambient permit system known as APS. EPS approach often makes use of a set of emission zones within which emissions of a particular pollutant are treated as equivalent, and hence the permits are defined in terms of the levels of emissions rather than in terms of the effects of these emissions on the ambient air quality. The environmental authority determines an allocation of permits to each zone, and polluter within a zone trade permits on a one-to-one basis. the environmental authority issues a fixed number of permits for the region as a whole, and the subsequent bids and offers of participants generate a single market clearing price. From this perspective, EPS is a system in which the entire region is a single market, though it is possible to encounter continually more finely divided system of zones designed to take into account the spatial character of the airshed. However, regardless of the total number of zones, each pollution source will lie only in a single zone and will consequently operate in only one permit market for a given pollutant. There are no trades across zones, and each zone is a self-contained market with its own price for the permits determined by the polluter's demand for permits and the supply as determined by the authority. EPS is a simple system which works well in the case of uniformly mixed pollutants. Uniformly mixed pollutants are the pollutants emitted by many sources in a region, resulting in a relatively uniform concentration level across the region. Non-uniformly mixed pollutants are the pollutants that have different effects in different areas depending on where they are emitted, like water pollution from factories, sewage and runoff from agriculture. For non-uniformly mixed pollutants, however, trade under EPS could result in violations of ambient quality targets. For instance, if any source is located in a more sensitive area, then its increase in emission by some amount will do more damage than the damage avoided by another source by its emission reduction in non-sensitive areas. To get around this problem, the ambient permit system was proposed, where the permits are defined in terms of the pollutant concentrations at the receptor point. Permits are denominated in the units of damage at receptor. There is a separate market in permits at each receptor, and firms must trade in as many markets as their emissions affects the receptors. Firms thus operate in a number of markets for each pollutant and is subject to a different weighting parameter in each market. The assembling of the requisite portfolio of permits could become quite complicated and may hence enhance the transactional cost. The system of ambient permit system may also result in an increase in the long range transport of pollutants. Both EPS and APS have their own set of problems, and in order to tackle these, economists have proposed a number of different trading rules. All basically work on the principle of permits being denominated in units of emission. Three very well known trading rule systems are the pollution offsets, the non-degradation offset and the modified pollution offset. The pollution offset system imposes a rule that the ambient quality target may not be violated at any receptor point. However, this may result in worsening the ambient quality up to the target level and an increase in the total emissions. The non-degradation offset system imposes the additional constraint that total emissions may not increase as a result of trade in permits. Finally, the modified offset system allows trade in permit to make sure that both the pre-trade quality level and the target level is not violated. As Atkinson and Tietenberg in 1987 point out, the simple offset system is ruled out because it is considered incompatible with environmental quality objectives. No general conclusion can be drawn as to the relative cost effectiveness of the modified and non-degradation offset systems. Next, we shall discuss the allocation of permits. There are two options that can be considered in order to allocate permits. First is auctioning. There are two alternative designs for an auction system. The first is the simplest design, a single price auction whereby firms submit sealed bids for permits. Permits are then sold to the highest bidder for a price that could represent either the lowest accepted bid or the highest rejected bid. This mechanism encourages the strategic behavior in a way that if a bidder considers its bid to be marginal, then understating their true WTP might be beneficial. The second alternative is an incentive compatible Groves mechanism whereby the highest bidders win the permit, but the winner's own bid never affects the price it pays. The Groves mechanism is influenced by Vickrey second price auction whereby the highest bidder pays the price bid by the second highest bidder. Auctioning imposes an additional financial cost on the firms in terms of the payment they initially make for their permits. Second, grandfathering. It refers to giving away permits freely to the firms. This process may adversely affect the political attractiveness of auctions. Grandfathering has therefore been favoured in existing permit schemes as the revenue gathered could be used to restore the environmental damage or for subsidizing the improvements in the pollution treatment capital. Revenues could also be used to allow the reductions in non-environmental taxes. Although grandfathering system has certain benefits, they have been widely criticized in terms of discrimination against new entrants to an industry or area who must pay for the permits which existing firms were given for free. Grandfathering creates rent for those firms who receives the permits. We could therefore expect resources to be wasted in rent seeking behavior by the potential permit holders. Let us now discuss the problems with tradable pollution permits. First is the initial permit issuance. The basic model discussed indicates that the initial permit issuance makes no difference to efficiency if a cap is set on the overall number of the permits and trading is allowed. However, many recent proposals for emission trading involve auctioning. The rationale behind it is explained in terms of three effects of the marketable permit system imposed in conjunction with taxes and income. First is Pigouvian effect, which states that the society is better off because of less pollution. This effect is always positive. Second is the tax interaction effect, in which the permit system exacerbates the inefficiencies of the labor tax. This effect is usually negative. And third is the revenue recycling effect, wherein the revenue from auctioning of the permits can be used to reduce the inefficiencies due to the income tax. This is always positive. The third effect goes completely missing when the permits are freely allocated. So, the society is better off when permits are auctioned, bringing the revenue into the treasury. Second is the market power. The previous model was based on the assumption of perfectly competitive permit markets in which each individual firm had no control over the market price. This is a reasonable assumption in the presence of large number of similarly sized firms operating in a market. However, the scenario will not be same in presence of only a few firms, and especially if there is one dominant or large firm, as it can influence the permit price through its own buying and selling behavior. Any firm might be interested in influencing the permit price in order to minimize its cost of compliance and to put its rivals under some advantage in the product market. Consider a firm with a relatively large stock of permits. This firm can sell the permit and earn revenue. The cost it incurs in bringing those permits to sale is given by its marginal abatement cost, that is MAC. Now, if the firm has the monopoly market power, the firm may increase the price of the permit by restricting the number of permits sold on the market. This leads to deadweight loss as the dominant firm spends too little on abatement for it sells fewer permits, whereas the other firms spend too much on the abatement. In the monopsony case, the firm with market power spends too much on abatement and buys too few permits relative to the competitive case. Third is the transactions cost. The transactions cost comprises of the cost of trading, negotiating and concluding deal with the regulator. High transaction cost may prevent total cost from being minimized by posing a barrier to permit trading. There could be three broad sources of transaction cost that might arise in permit markets according to Stevens in 1995. First is search and information cost, which involves identifying the potential buyers and potential sellers. These costs may be large in case of pollutants with spatial or temporal considerations. Second is bargaining and decision making cost, which includes the cost of negotiation and finally agreeing on a price trade. Third is monitoring and enforcement cost, which may be borne by a regulatory agency. Transactions cost may be considered as impediments to trade and can determine whether the initial allocation of permits across sources matters. It is also important to ascertain whether the transaction costs are increasing or decreasing with the volume of trade. For example, they could fall as the volume of trade rises due to learning by doing effects. Uncertainty as to whether the trades will be approved by the regulators, for instance, where trading rules are in place to handle non-uniform mixing problems, is also very important in deciding the effect of transactions cost on the efficiency of a TPP system, according to Montero in 1997. Search and information costs become large for the heterogeneous permit market. For example, if one is dealing with the ambient permit market, in which every permit must be viewed differently in terms of its impact on ambient pollution, identifying likely buyers and sellers may be difficult and costly. High transactions cost could be a reason for low cost savings achieved by various permits trading schemes operating for air pollutions in the USA prior to 1990, according to Tietenberg 1990. High transaction cost led to the failure of various other permit trading schemes like Fox River scheme in Wisconsin, despite the presence of significant potential cost savings. One practical solution proposed by experts in this regard is to introduce an electronic bulletin board service where offers to trade are posted in terms of prices and quantities of permits. This can go on a long way in reducing the transaction cost, as a barrier to cost minimization is for the regulator to run. A well-designed but complex system of ambient pollution permit may look efficient on paper, but transaction cost associated with it might be very high. A simple permit system may perform better in this regard. Thus, permit markets may be designed in a manner that keeps the transaction cost low. Fourth is the market thinness. Marketable permits pose problems when the market is generally thin. The main rationale for marketable permits is to equalize the marginal control cost among the firms. However, this may not be accomplished if there are only a few firms in the market, as the transactions then may be infrequent or non-existent. although the resulting amount of pollution will be equals to the permit issuance, but cost will be excessively high. As the firms in a permit market compete with one another in a good market, withholding permits can then be used as an entry deterrent, or permits can be used in other anti-competitive ways. Let us now discuss the taxes versus permits. There are various policies alternatives to that offer the least cost solution to the pollution problems. Tradable pollution permits and pollution taxes are both capable of achieving it. This section reviews these two alternatives. Innovation and cost saving over time. One very important advantage of economic instruments over design or performance standards concerns the dynamic cost saving. Suppose a firm could install a cleaner technology by adopting a production process with lower marginal abatement cost associated with it. This may incur a cost, but benefits accrue in terms of abatement cost savings. These benefits can be shown to be greater under a pollution tax than under a uniform standard. A tax system relative to a standard is expected to result in a progressive reduction in both the abatement cost and emission levels over time. Milliman and Friends in 1989 argued that emission taxes provide higher incentives for the firms to innovate cleaner technologies than emission subsidies or certain forms of tradable permits or uniform standards. The most commonly practiced pollution policy of command and control regulation result in lower incentive for the cost reductions in pollution control than the market mechanism. The encouragement to reduce the cost provided by the market mechanism has been referred to as over the long haul, perhaps the most important criteria on which to judge the environmental policies. However, taxes may do better than the tradable permits in this important aspect of the environmental policy designs. Uncertainty. Uncertainties over control cost can turn out to be higher than the thought due to the following reasons. Uncertainties exist because, first, we may have little experience with large cuts in the emissions. Second, we do not know what future technologies options will be. Third, we do not know what the do-nothing level of emission will be relative to which achievements are measured and targets set. Pizer 1999 and 2002 work argues that with the permit system, emissions are unchanged over the perfect information scenario, but cost of control rises. This stability of emission in the face of uncertainty is one reason why TPPs are indeed favored over the taxes by some environmental lobbies groups. Pizer also argues that if there is some threshold beyond which further pollution emissions will impose very high cost, the greater certainty over emission levels that comes with permit market is preferable. If instead damages rises smoothly with increasing emissions, the threat are not so bad and we prefer the greater certainty over control cost which come from taxes. This preference for taxes over permit is reinforced when one remembers that it is not current emissions which is the cause of the great worry about climate change, but the overall stock of greenhouse gases in the atmosphere which changes very slowly. Now, we will summarize what we have discussed in this module. A conclusion which might be drawn from this chapter is that economic instruments such as TPPs are considerably efficient enough over the command and control approaches such as design and performance standards. However, as several recent surveys of actual pollution control policy in the OECD have shown, governments have made relatively little use of the economic instruments as yet. A comparison of OECD surveys with more recent surveys have shown that use of economic instruments has increased over time. Yet, the impression remains that the economic instruments are still used rather less than their theoretical advantages would seem to warrant. And even where economic instruments are brought in, this is sometimes with the major purpose of raising the revenue rather than changing behavior.